Physics Part 13. Two forces are question number 5. Two forces are magnitude 450 and 240 Newton respectively. Determine the maximum magnitude of the resultant force and the minimum magnitude of the resultant force. The resultant force when the forces act at right angle to each other. Use a vector diagram, then check your result by calculation. Number 6. A boat can be rowed at a speed of 7.0 km per hour raised to power -1 in still water. A river flows at a constant speed of 1.5 km per hour raised to power -1. Use a scale diagram to determine the angle to the bank at which the boat must rowed in order that the best travels directly across the river. Number 7. Two forces act at point P as shown in the figure. Draw a vector diagram to scale and determine the resultant force. Check your work by calculation. Exam style questions. Question 1A1. Explain what is meant by base unit. 2. Give 4 examples of base units. B. State what is meant by the derived units. C. 1. For any questions to be valid, it must be homogeneous. Explain what is meant by homogeneous equation. The pressure P of an ideal gas of density P is given at the equation P is equal to 1/3 Pc square, where C square is the mean square speed, that is, it is quantity measured by the speed. Use base units to show that the equation is homogeneous. 2a. Determine the base units of the work done. 2. The moment of the force. 2b. Explain why your answer to A mean that caution is required when the homogeneity of an equation is being tested. 3a. Distinguish between the scalar and vector quantity. B. A mass of weight 129 newtons is hung from 2 strings as shown in the figure. Now determine by scale drawing by calculator and your calculation the tension in RA and RB. C. Use your answers by determining the horizontal component of the tension 1 RA and 2 RB. Comment on your answer. 4. A fielder in a cricket match throws the ball to the wicketkeeper. At one moment of the time, the ball has horizontal velocity of 16 meters per second raised to power -1. A velocity in that vertically upward direction is 8.9 meters per second raised to power -1. A. Determine for the ball its resultant speed. 2. The direction in which the traveling relative to the horizontal. B. During the flight of the ball to the wicket keeper, the horizontal velocity remains unchanged. The speed of the ball at the moment when the wicket keeper catches it is 19 meters per second raised to power -1. Calculate for the ball just as it is caught. Number 1. It is caught at a vertical speed. Number 2. Angle that the path of the ball makes with the horizontal. C. Suggest with reason whether the ball at the moment is caught is rising or falling. There are maths rules. Sine rule for any triangle. A over sine A, B is equal to B over sine B, and C over sine C. Cosine rule for any triangle. A square is equal to B square plus C square minus 2BC cos A. B square is equal to A square plus C square minus 2AC cos B. c square is equal to a square plus b square minus 2ab cos c.